This is free response question number 5 on the 2024 AP Calc AB exam. Okay, so they gave us this curve defined by x squared plus 3y plus 2y squared equals 48. And then they say it can be shown that dy dx is minus 2x over 3 plus 4y. Okay, so now, first part says, give me 1 second. Okay. There is a point on the curve near 2, 4 with x-coordinate 3. Use the tangent line tangent to the curve at 2, 4 to approximate the y-coordinate of this point. This is asking to use a linear approximation, and the key word here is even tangent line. So probably a good idea to find the equation of the tangent line. That would give you partial credit, probably. Okay, so to find the equation of the tangent line, we need a slope and we need a point. We got a point, 2, 4. We need a slope. So we're going to use this point and plug it into dy dx, which is the slope of the tangent line. So dy dx is, we want to evaluate it at x is 2 and y is 4. Okay, so we plug in x is 2, y is 4, and you should get minus 4 over 19. Okay, so the equation of the tangent line, I use point slope form first. Y minus 4 is equal to the slope minus 4 over 19, x minus 2. And I just move this 4 to the other side. Okay. Therefore, using a linear approximation when x is equal to 3, we can say y is approximately minus 4 over 19. We plug in x as 3 into our tangent line, 3 minus 2 plus 4, and simplify it to minus 4 over 19 plus 4. I would just leave it like this. I don't think in the AP exam you need to fully simplify. This should give you this should give you full credit, if I remember correctly. Otherwise, you can just do you can make it one fraction too. But that's highly prone to error, so I would just leave it like this, honestly. If I were the grader, I would set this as the answer. Okay, next. Is the horizontal line y equals 1 tangent to the curve? Give a reason for your answer. Okay, so I said since the tangent line touches the curve at 1 point, the y-coordinate of the point must be 1. Okay, it's a horizontal line, the y value is constantly 1. So that means no matter the x value, y is 1. So when it touches the curve, the y-coordinate has to be 1. Okay, it's a horizontal line. Slope of the tangent line is 0 also. That means dy dx is the slope of the tangent line is equal to 0. Okay, so when we just said, but the y-coordinate must be 1, so I plugged in y as 1 there, which means x is 0. This, by the way, is the dy dx, right? I plugged in y as 1. Solve for x is clearly 0. Now we need to check if 0, 1 is on the curve. So we plug in 0, 1, x is 0, y is 1 into here. 0 squared plus 3 times 1 plus 2 times 1. That's 3 plus 2, which is 5. Clearly does not equal to 48. So it's not on the curve. Therefore, y equals 1 is not tangent to the curve. The curve intersects the positive x-axis at the point square root of 48, 0. It's interesting that this is not in simplified form, but I allowed it in the question, but whatever. Is the line tangent to the curve at this point vertical? Give a reason for your answer. So when the slope of the tangent line, or when there's a vertical tangent line, the slope is infinite, meaning dy dx is undefined. So that's what I said here. It would be a vertical tangent if dy dx is undefined, or you'd be dividing by 0, essentially. So when we plug in x is square root of 48, y equals 0 into our dy dx, remember dy dx is slope of the tangent line. So I should have made a typo there. Let me fix it. Okay, so this should be, this should be not equal to undefined. Okay, so not equal to undefined. So therefore, it is not a vertical tangent line. Okay, so as I said, we need to be divided by 0 in order for it to be undefined, but clearly that's not happening here. We'll be dividing by 3, so that's valid in the math work, but this is not what we want in this problem. We want it to not work. Okay, part D, for time t greater than or equal to 0, a particle is moving along another curve defined by the equation of the sky. At the instant the particle is at the point 4, 2, the y-coordinate of the particle's position is decreasing at a rate of 2 units per second. Oh, this sounds like related rates. At that instant, what is the rate of change of the x-coordinate of the particle's position with respect to time? Okay, so what did they give us? What did we want to find? This is what I always start with in related rates. You give us that x is equal to 4, y equals 2, y-coordinate is decreasing at a rate of 2 units per second. So dy dt is equal to -2. Okay, negative because it's decreasing. And we're asked for what dx dt is, rate of change of the x-coordinate of the particle's position with respect to time. Okay, so the equation, we want to differentiate it. We need to use implicit differentiation. So it's 3y squared dy dt. Here we need product rule. 2x dy dt plus 2y dx dt is equal to 0. Okay, now we start plugging in things. We know y, we know dy dt, we know x, we don't know dx dt. And that's what we want to find. So we plug things in, you only have one variable left. Okay, so now you just start solving. So move all this to the other side. This is just 4. So 4 dx dt is, this is -24. So it becomes +24 when we move it. This is -16, becomes +16 when we move it. So divide by 4, dx dt is 6 plus 4, which is equal to 10. It's 10 units per second. So don't forget your units there. Okay, and that's it for this question.